All right, so getting ready to wrap things up here. Next new concept is something called rotational inertia. Um, as you've seen, we keep having these connections to some of our previous mechanics that we've seen. We've had velocity, we've had acceleration. Um, Rotational inertia is dealing with how the mass of an object is distributed, and so different shapes have different rotational inertias. What this is leading to is building up sort of a mass definition that's going to go along and help us do angular momentum in question 10. Rotational inertias are a little bit tricky because every different shape has a different formula, and if it's an irregular shape, then again it's a big calculus 2, calculus 3 problem to set up and find it. So we use capital M and capital R typically in these formulas because we're dealing basically with a big system of points is how we look at it, and the distribution of materials. Part of this information is ready. We've got kilograms in the requested units and kilograms in our information, but the meters squared are not yet represented. And it's a radius, so that was good, but we just need to do a conversion right quick. So think cents and dollars, centimeters to meters, 100 cents, so 100 centimeters makes 1 meter, similar to a dollar. That's going to mean that this radius, it's going to bump the decimal 2 times, or you can manually divide in the calculator. It's going to be 0.2912. When I wrote this formula, you may notice I left some space in front because depending on the shape, what typically happens is you still have mr squared, but you might have a 1/2 or a 1/3 or a 1/12 or some other number in front because of the distribution. So this one, we don't have a number associated with it. A hoop is just the plain mr squared. Then we can just plug in and go. So 2.35 kilograms multiplied by the radius, so 0.2912 meters that get squared. So now that's not a problem anymore. This is going to be meters that get squared. That's going to fix our units. Evaluating here, 2.35 times 0.2912 times 0.2912 again will give us 0.19, 4 decimal places because it's small, so 1993. The units are basically those just kind of mashed up with each other, so kilograms times meters squared.